So good evening officially to all of you, and welcome to Season 6 of OTF Connects. We're just getting going. This is our second week. My name is Susan Watt, and I'm one of 4 moderators of these wonderful webinars. My job is to be behind the scenes. So Scott and I have met ahead of time, and I've uploaded content, and from now on I just kind of hang out in the chat and help out when necessary. So I'd like to introduce Scott McKenzie. Scott and I have known each other for a few years. He's a local teacher in the Waterloo Board and has done some very exciting and wonderful work in the area of bringing the idea of coding to his young students. He teaches in primary, and I've been in Scott's classroom. It's a very exciting, invigorating place, and he's been doing OTF Connects webinars for us for the last couple of years to great comments from participants. So Scott, we're really happy to have you here. I'm really happy to be here behind the scenes helping you out, and I'd like to welcome you and turn things over to you now.
Thank you, and good evening, everyone. Thanks for the kind words, Susan and Stacy. Your comments in the chat. Thank you so much. It's great to be here tonight. I'm really excited about what I'm sharing, and I really believe in it. I think that it is great for students, and it really is helpful. So we'll talk about this tonight. Feel free to throw your questions up in the chat. I will try to keep an eye on that. Susan is really great about letting me know if I'm missing something. I'm going to be going at the speed of the audience, so hopefully that'll work with everyone. If things are going too fast, you can let me know, and I'll slow down so that we can make sure everybody gets the most out of the evening. So real quickly, I'm on Twitter, Scott McKenzie 27. I share my learning there and what we do in class. Also, you can connect with me on Twitter. If we follow each other and you have questions, you can DM, you can direct message me, and I'll do my best to answer your questions afterwards as you try this in your class with students. So one of the questions I often get from people is, why integrate coding in the beginning? Why do that? Because it is extra work. It does take extra time to introduce the students to the tool. But what I've found in my classroom is that it also deepens their understanding. It deepens their knowledge base afterwards. It gives them another way of doing these problems, especially in math, where they're approaching it from a different angle than they might have otherwise doing things the traditional way. So I think that it's a really great way. It depends on where you're using it in your program. It's not always the first thing you should do with the students, perhaps in a unit. But bringing it in once they're learning a concept or understand a concept, it really helps them to understand it better afterwards. Something that is huge for me is some of these programs that we use tonight, they look a lot like math apps that you might use on an iPad or on a tablet. And the reality is that's the starting point. But then the students are in Scratch, so after they've seen the program and tried it, they can also see behind the scenes, so they can see the code, they can see how the program works, they can start to tweak things and change things, they can create their own project from it, they can remix it, they can bring their mathematical learning in and apply it and use it in that program. So first off, before we go any further, in the chat, if you could please put a number just to tell me what your comfort level is right now with coding. So I've written what they are there, but there might be some coding rock stars here tonight. There might be people who've tried it once or twice. Okay. Oh, nice, Python. And logo, very cool. Old school. Okay, so I'm seeing a lot of 3s and then some people just starting out and all the way up at 5 as well. Jennifer, oh, that's interesting. Very cool. So as we go along here, hopefully I can keep everybody interested in what we're doing then. I want to keep everyone on board, but hopefully there's little tweaks that the people who are rock stars already can use as well. We wouldn't have Scratch if it wasn't for Seymour Papert. Seymour Papert, 40 years ago, was doing the things that we're trying to do today with kids. He was a mathematician at MIT in the United States, and he was phenomenal. He had students as young as kindergarten coding on computers. They had these gigantic robots at the time with long wires that hooked them up to the computers, and they would code the robots, and there was a physical pen that the robot would put down on paper, and it would draw, and it would create things. And so he got so many people started with this whole concept of thinking about how students can be the artists and the creators on a computer rather than just the consumers. So we do have a really short video from Seymour Papert that we're going to show on the next slide. And I'd like you to just watch that, and then when we come back, I want to talk just a little bit about how we could create Mathland in our classrooms. The link is down in the chat, so if you want to go off and watch it, it's literally like less than 1 minute and 20 seconds.
And I'll just say once again, because we ran into this a couple of times in the last week, so for those of you who are new, it looks like the slide has the video, but that is just a screenshot. So go over to the chat, and I've just posted Seymour Papert's Mathland with a YouTube link. If you click on that, it will open that link up in your own browser on your own computer, and then you can go and watch it, and then come on back to Blackboard when you're finished.
Yes, David, that's absolutely right. He was a student of Piaget. When you come back, just give a green thumbs up to let us know that you've seen the video. Thank you. Okay, so I see a lot of people are done. So what are some ways you have students experience math now in your class? Rather than just doing the math, how do you have them experience? And I should have written mathematics on here, so that's my bad. I'm just noticing that now. But what are some ways you have students truly experience mathematics in your classroom? If you could write in the chat and share, please. Catch and release. Interesting. And it is true that they have anxiety with math, a lot of students. And one of the neat things about the coding is that they realize as they do it that they're expected to fail several times before they get it right. I actually take that and I apply that to when we do math in our class, and I talk about the very fact that it's just like coding. We're going to have to put together an idea and try it a few times before it works. Okay, those are some great suggestions and ideas that I see in the chat there. And real life situations are huge. As much as we can, we should go to the real world. Pumpkin exploration sounds awesome. Hopefully there's some pumpkin seeds at the end of that. So on the slide here, there's another link. You can't click on the link in the slide like Susan has said, but if you could go to Scratch and register as an educator. If you go down to if you click on this exact link, or if you go to Scratch and scroll down to the bottom, they have an educators section, and you can register as an educator. And I suggest doing this because in about 24 to 48 hours, you will have an educator account, which means you can put all your students in so that it's not asking for parent emails. It's all done through you. So it's the best practice of how to set your students up in Scratch, especially with the younger children. You can easily change their passwords with them and kind of control what they're doing on Scratch. You can see everything that they do, and they can share it with you quite easily. So if you want to go to that link now, which number? No phone number is needed. No worries. So if you're just joining the session, I'm just having people sign up for a Scratch Educators account. As soon as they apply for that, they'll be able to work in Scratch, and we're going to be doing that. So if you could please register for your Educators account, and then what we're going to do is we're going to jump into Scratch and start playing around, but within 24 to 48 hours, you will be able to put your class on there. It happens very quickly. I've never had any problems doing it or heard of anyone having problems doing it. Phone number. Okay, well, my apologies. They might ask for your phone number then. I didn't remember that. This is MIT, so there's no other reason that they're using it. There's no advertising done. They would never do anything with it. It's just a university, and it's kind of protection for them to, if they need to check if you're a teacher. Yes, Sarah, I believe people are setting up their accounts right now. Again, if you're just getting here now, please go to the link that's on the screen and register for a teacher account on Scratch. And as soon as we have all been able to do that, we can move on. If you're unable to register tonight, don't worry about it. What we can do, you can go to Scratch just on the internet without even signing in, and you can just click the Create button and you can explore. All the links of what we do tonight will be shared later after the session. But if you can, please sign up now. It just will make it easier for you to get on with your class as soon as possible. So we'll give about 2 more minutes for people to sign up, and then we're going to move on and we're going to start. So hopefully that'll let most people get on. Good. So quickly, while people are just finishing signing up, for those of you who are coming from Scratch Junior, this is a quick comparison of how the two programs are set up. Hi, Mark. Yes, there is a downloadable version of Scratch. There's actually two now. That's not really what we're focused on tonight, but you're absolutely right. And for people who don't have regular internet access, there is two versions of Scratch that can be downloaded now. So Scratch Junior versus Scratch. This just shows you how, if you've been using Scratch Junior with students, it relates very nicely to Scratch. And there's a lot of opportunities for students to move from Scratch Junior right into Scratch, and things will seem familiar to them. You can see that the sprites are on the left side in Scratch Junior, and they're at the bottom in Scratch, and that both programs have the palette code blocks. I would suggest with grade 1 that you start with Scratch Junior, but then move on to Scratch. So at my school, I have the JKs and the Ks working with Scratch Junior, and when they hit grade 1, they come down and they try Scratch with me. So they seem to be able to make the adjustment and move, but they still use Scratch Junior in the classroom, so they use both. Okay, so I'm thinking that most people that wanted to have set up an account. So what I'm going to do now is I'm going to jump into the first project. And before we move on to the actual project that's pre-built for you, which I will do, I'm first going to ask you to just create a new project in Scratch. I'm going to run through how to do things here on the slideshow and live, and you can just give it a try on your computer. Alternately, you can also watch me right now. If you've only got one device running, you can just watch what I'm doing. The completed How Many project is available, and you will be able to access it later, which already has the code in. But I'm just going to show you how we create something like this. Is there anyone who's not ready yet? Is there anyone who's just needs a second? Throw it up in the chat, or I'm going to move into Scratch. Oh, okay. 1 second. I'll move slowly. Okay, so it looks like everyone's set up, and Monica, I apologize, you've had to jump back in again. In Scratch right now, I'm hoping that you're seeing on the screen what I'm seeing on the screen, and that we're all looking at the Scratch start page. And Create is right beside Scratch, so if you want to click Create, please. If you get a funny message that you require Flash, if you go up to the top of your web browser and you click, you'll be able to turn Flash on manually, and that should help. So you don't have to go on Scratch. You can watch me if you prefer, but if you try it along with me, if you have two devices, that would be great. So, first thing we're going to do is get rid of the cat. So, if it's students on a Chromebook, that's a 2-finger tap, but on a computer, that is a right-click, and we delete. If you want to go, oh, sorry, I did that rather fast. If you want to, go to the little head beside New Sprite and click here. Then select a ball, just a plain yellow ball. And you have these different colors of ball. In Scratch, what it's done, yes, sprites are characters. Sorry, Gurpreet. And I'm sorry, I'm reading the chat. Some people can't hear me, so I apologize. Okay, so we have these different colors, and Scratch has made it look rather 3D with that lighting, and I don't want them to look 3D right now. So something students love to do is customize. And if you click on the ball under costumes, so it's by default it's in scripts, and if you click, Deanna, on costumes, and you click on the sprite itself, then what you can do is click the paint bucket, and then you can select any of the standard colors here and click inside the circle and it will turn it red. Now, a quick way to get another sprite if you want something the same, again, that right click, you can duplicate a sprite by right clicking on it at the bottom. So if you right click on the ball, you can duplicate the ball, and you'll have two red balls. And Scratch makes it easy because if you click on it at the bottom, it shows you which one it is on the screen. So I can see I have two of those. And then if I duplicate again, I can take ball 3, and ball 3, I got to make sure I'm on the right ball, ball 3, I can click on it, and I can make it a different color. Maybe we'll do blue. Okay, then you can drag these, switch back to scripts, and you can drag these anywhere on the screen. And students instantly have a manipulative that they can work with on the screen. So now they have these balls that they can do things with. So we have red and we have blue. And what I can do now is I can add a bit of code to make these interactive and to make them do something. So, again, for color change, I'm just seeing the chat. If you switch to costumes and you click on the costume, the actual sprite, and you click color shape with the paint bucket, then you can select your color and drop it in here. Okay. So in Scratch, when we start the program, we always start it by clicking the green flag. This is something that is universal in Scratch. So anything you want to happen at the beginning, you pull out from the Events palette, you pull out the When Green Flag Clicked. The palettes are all these different colored, key-coded, color-coded palettes, and Events is how we start a script in Scratch. And you can tell it's starting because it has a curve at the top. Nothing can go on top of that block. That is how we start. Oh, Asa, if you're seeing backdrops, then you are on the stage, which is also, you can program things into the stage. You've accidentally, I'm clicking on the stage now on my screen. If you want to make sure you're on the sprite itself and not on the stage, click on the ball itself and then you can change things. So under Events, I've pulled out when green flag clicked. And when the green flag is clicked, this will make sense later, but I'm going to Looks and I'm pulling out the Show block. And I'm going to Motion, and I want the blue circle to be exactly where it is right now. So I'm dragging out this block here. And for the students, they don't have to know what this spacing is yet. So the screen is split. Y is the vertical axis going up and down, and X is going left to right. And they don't have to know all the numbers right away. They can play and they can explore without knowing how the entire grid system works. This block right now is where the blue circle is. So if I pull that out and I drop it up here, and I were to move that blue dot, that blue circle, if I click the green flag, it's going to go back to that original position. Under the event is a purple show block. It is purple, so it's under looks, and it's a show block. And then the motion block is the current position of this circle or ball. If I click on ball 2, I'm doing the same thing. I'm going to events. I'm pulling out when green flag clicked. Go to looks. Pull out the show block. Drop it in. And then for ball 2, which is here, its position on the screen currently is this XY position. So I'm going to drop that here so that if it gets moved, it will come back. Oh, yes, there is a way to make them bigger. Sorry, I can absolutely do that. Is that helpful? Okay, right. I do this with my class sometimes too when we're doing something new. Sorry, I didn't think. And perhaps I can do a large stage and still show that. There we go. So this is exactly what I'm going to do in the first ball as well. So I'm going to the events. I'm pulling out the green flag clicked. Going to looks. Show. And finally to motion. And this is the current position of the first ball. So I'm going to pull that out as well. You don't have to know what minus 186, 112 means at this point. It's not something that we have to have students do. They'll figure that out as time goes by, but they're experiencing the math. So if I click the green flag, this just puts all the counters or all the balls or all the circles back to the original position. Deanna, how did I do that? To show the blocks bigger, there's a plus and minus down at the bottom right-hand corner here. And if that's not big enough for your students on a projector, you can also go to Edit and make it a small stage layout. Okay, so now what we've done is we've had it so that when we reset our program, when we reset our app, all the circles will go back to the original position. Now, the next thing we want to do is, because we're saying show, we might at some point want to hide these sprites or these counters. So if you go back to events and pull out a when this sprite clicked and go to looks, you can pull out hide. And this means if I click on the first ball, it vanishes. So if I were showing my teacher a certain amount, I could quickly click it and it would disappear. Now clicking it again doesn't bring it back. To bring it back, we reset the whole program. So Brenda, if you've missed part of what we're doing, I have the completed project which I will share with you later. And if you follow along now, I think you'll be able to catch up. We haven't gone too far yet. So one of the neat things about Scratch is that you can take this code here and you can drag it. And so I love showing students this because it cuts down on how much time they have to spend with all these simple tasks. So if I drop that on ball 2, ball 2 has that code now. And I can drop that on ball 3. And Monica, if you're lost, what I'm going to do, I'll pull up this project in a little bit, and there'll be a video tutorial available as well afterwards. All those links will be shared with you, where I walk through this, and you can pause the video as you go. So we now have the 3 circles with their code. You'll notice it's overlapping on one of these, but it doesn't matter. The project's being created on Scratch, which is scratch.mit.edu. You can go there right now and you could create the project. Susan, maybe you could put the link for Scratch, scratch.mit.edu, if anyone hasn't been able to get here yet. Thanks, David. When I press the green flag, the ball doesn't reappear. Okay, so then you troubleshoot. Do you have the show block linked in underneath the green flag? Because if you do, then it should reappear. To copy it, all you do is you take it and you drag it over top of another ball that you want to have that code in, and then it copies over. If you need to get rid of any code, you can drag it into where all the blocks come from and let go, and it disappears. I would also suggest you click the Save Now button every now and again, just in case you lose connectivity. So it's great to have the three circles here, but the students might want more. So another thing that they can do here on the first ball, I'm going to go to Events, and I'm going to pull out the When Space Key Pressed block. And I'm going to change Space Key to the letter A. So I might want this circle, I might want another one below it. So what I'm going to do is, when the A key is pressed, if you go to Control Blocks, then you'll see down near the bottom, create a clone of myself. And then in the beginning, for students, if I click it, you might say, well, I don't see the clone. It's right over top of the first one. So if you pull it away from the first one, then it shows up. So this is a great starting place for students. They can do this many times, and then they can show whatever numbers they want. So they have an interactive counter program where they can bring things. If I move to the blue ball, which I've disappeared, and create clones, the clones won't show up. So they have to be careful not to click on it, but just to drag. So if I start over, if I create a clone and I click and pull, it doesn't make the first circle disappear. A more sophisticated way to do this is you can pull out from these same control blocks when I start as a clone. And with students, if I mention to them that the y-axis is up and down, they can experiment themselves. And I tell them that if I want to go under, I have to do a minus, because I'm taking away from its position, and try different numbers to see what makes it go in the right spot for you. So they might try minus 60, and then if I press the A key, it just automatically adds another one 60 pixels below the first. Okay, so this is how you would build this program. There is a finished version of this program that the link will be shared with you, and there's more set up on the screen that you can work with later. You can't do the A button. So to get the A button, the run function is the green flag. When you click the green flag, make sure you click the green flag, and then that'll work. And just make sure you've selected A. Yes, and you can change the whole program over to French. You'll notice on Scratch that right beside Scratch there is a globe, and if you click on that globe, there are many languages. One of the really cool things, the video link, sure, Susan, that'd be great that people could access later. Any language, if you have students that have come from a different country and they might have trouble, they might be EFL in your classroom and they're just, you know, they're trying to do things, and then having them do something on Scratch, they can see the blocks in their native language and can work in that, and that's reassuring for them. It's very helpful. So it's great that all these different languages are supported. It's fantastic, really, and they're all there. So I mean, not every language, but quite a few, and French is definitely there. To get the languages, it's the world that's right beside the word Scratch at the top, beside File. I'll just click it again. Okay, good. So I'm going to move on. This program here is just it's a starting place. So it's a really simple way to get students in and looking at numbers. I want to quickly show you a couple of other projects related to this. So if I can find them. So we can build this right into a Rec and Rec. And Steve Waborny, he's awesome, and he does Splat Math. And this is a similar program with similar functions, but here I've drawn this splat as a sprite and added it, and the splat will hide some of these circles. So for students, A, S, D, F, G, H, this creates the different circles, and then the students can place this over top, the splat, and they can be tricky. So they might want to show these as hidden, and then students have to figure out how many could be hiding behind it. But they also might want to say, well, under D, I could add one more and then hide that. So what this does is it creates a situation where students are really thinking about how many circles could be behind the splat. What's a reasonable answer? And there's a lot of communication and things that go on with the students. So again, the code's fairly simple. This sprite, the green blob or splat, with the 1 key it shows, with the 2 key it hides, so shows and hides. And they can take turns setting it up and sharing it with each other. But again, this is based off of and built off of that very first program. What we're wanting, Deanna, in the younger grades is the students to go to the project first, which is already created for them. And they start with the program using it, and then you watch very quickly, they'll figure out how they can change the costume. So then they'll say they'll create the color waves. So they'll be black and then red and then green. And they'll say how many green circles could be behind the splat, how many red ones. There's a lot of things the students naturally start to do as they learn how to control it and how to change things. They'll start to add things in. If you've done other coding projects, they'll pull some of the code and some of the things they've learned somewhere else. I tell them how the program works, I get them started, but then I let them explore and I let them find something different, and they share with each other. And when one student discovers something new, they share it with others. This grows very quickly and rapidly with the students, because once they figure out that they can't really break anything, then they feel very free in jumping in and exploring the tech. So I'm going to jump out of the Splat Math. This will be shared as well later. And the Rec and Rec, all I did here, and I basically took the same concept And this is really basic. I mean, if I look at the ball, it tells me here what it'll do. So when space key is pressed, create a clone of myself. So pressing the space key right now only clones the first ball. But the students have learned how to drag the code over. So if they drag this code over to all the balls, then what they're doing is they're creating it so that when this starts, they can create a second row of the balls that they can work with. And then I'll find out if I did that right, because we'll reset, and I'll press space. So I've got a second row. Save now is in the top right corner. You won't see it on my screen right now because I haven't changed anything in my program, but it's right around here. So here, in this program, if you look at the white balls on the end, this code here allows the sprite to move over to the right like it would on a rec and rec. And then I can drag that code here into the next ball and into the next ball, so that students are manipulating this like a rec and rec, then it works in a similar fashion. And if they don't line up right, I can tweak my steps that I'm moving, but this allows them to create a tool that they might be using in class. I won't really speak to that anymore tonight just because of timing, but I'm sure you can think of different ways you could use that. And I'm going to jump back to the slideshow now. And catch up on the slideshow. Mark, yes, my class is one-to-one, but that's not with Chromebooks, but I don't have them work one-to-one on the Chromebooks. I believe they're the same, yes, David. Someone can jump in if I'm wrong, but I believe it is the same, yes. Not quite. Well, there we go. But the concept of counting, so they're set up in 5 white, 5 red, so that they can count off different numbers. It's just another manipulative they can use. So I'll just catch up here. I've got slides in here about how this all relates back to the curriculum. So right in our curriculum, even though the math curriculum is getting a bit older now, even at this time, they had everything in here talking about how there should be a variety of ways that students are finding out and working with the math, and ways for them to explore it, and all the different opportunities, and to get it into the real world. And I think their real world more and more is becoming a digital world. So giving them those chances to apply all those math skills with coding is a great opportunity. And the mathematical processes, I see these showing up so much with coding. So just how do we get students to think about that? Just being mindful about which ones we're hitting when we're working on a project. So for problem solving, when students are trying to set up the code and make those circles move where they want them to, this really makes them think about how they're setting it up. And they have to think about the math. They have to think about, where things are on the stage, so that they're setting things up properly. The numbers relate to the position on the screen, and that's huge for them. I think that these apply when they're working on a project. So their mathematical model is basically the code that they're writing. If they found code that works, that's like a formula. Guessing and checking is built right into Scratch and into coding in general, because you do generally run things after you put some code together to make sure things will run. And then it is, of course, logical reasoning. And there's so many different ways to come at a problem and find a solution. So even just with that circle program, we could apply the splat math to it. We could turn it into a rec and rec. There's just many different ways that they can start to take it because it's so open. So, this is the link for Steve Wilborny's Splat Math. He has a bunch of math things on this blog. It's phenomenal. Susan's just shared the link to it. It's fantastic. I strongly suggest you check it out. There's just so many great ideas in there. He shares freely. It's fantastic. And I'm sorry if I'm going fast. I'm just trying to jump ahead so I can get to as many projects tonight as possible. And catching up to 2D shapes. So selecting different tools and computational strategies. This is another one of the processes. And we want to be careful to, I mean, I never think that coding is the best way to do something with students, but when it does work well, we do definitely want to introduce it to them and introduce how it works. So for me, one of the #1 ways to have students explore 2D shapes is to have them code them and to create them with code. When they do that, they really get an understanding of how the angles work. So for grade 3s, that 90-degree angle, smaller or bigger than 90 degrees, makes so much sense when they code something because they can instantly see whatever they put in, it shows up on the page. One of my students, grade 3 students, the other day, she was creating squares and rectangles in Scratch, and she was trying to make something different because my challenge became, try this. No, the links won't expire, Gurpreet. These are my projects on Scratch, so they always have that unless I deleted my account, which is unlikely. She wanted to make a circle, and so she was trying to get it to create the circle, and she kept playing with it and playing with it. And she said, I've got half a circle, but it's turning 180 times 1 degree at a time. I said, well, what do you think you'd have to do to get it all the way up to a circle? And so she looked at the numbers, she played with it a bit, and then she called me over and she said, it's 360. And I said, well, how many degrees do you think there are in a circle? And she said, 360. And so she literally discovered what a circle was just by playing on, not playing, but creating and working in Scratch. So I've had so many moments like that where students have those aha moments and they start to get things. So if we jump into a 2D shapes project, I'm going to have you jump into the link for the 2D shapes and save everybody a bit of time. Susan's sharing it now, so if you click on that link, we won't have to start from scratch. That was my bad joke. If you want to put a smiley face up, you can. All right, so I'm going back. Oh, thank you. You're too kind. And as you can see right now on my screen, you'll have this later. All these links, all the video tutorials are here. So I apologize if I'm going fast tonight, but you will have access to these later, and the video tutorial will help you. So I have instructions here for the students. The beetle has drawn half of a shape. What shape could it be? Can you code the rest of the shape? What code blocks will you need? I won't read the rest, but it does mention to them something that we'll look at inside here. So here's the project, and if I click on the green flag just to get it started, the beetle always resets to X, Y, 0, 0, and it points in direction 90 degrees. That means to the right. And so I talk about that with students. We do this physically with our bodies. We figure out all the different directions so that it makes sense to them. We kind of step out of the program and step back onto the screen so that this all makes sense to them. But 90 degrees is to the right for the direction they're pointing. Now you'll see in the program itself up here, it's saying that it's going to turn 90 degrees, which is not the same as pointing in the direction 90. So we also talk about what turning 90 degrees means. So that's right in the curriculum, and we do the 90-degree turn or a quarter turn. And so looking at the code right now, this is going to put down the pen, like Seymour Papert's old robots did, and setting the pen size to 3. A lot of students, if they're making this from the very beginning, they pull out this block instead. Oh, sorry. Hold on. They pull out this block by accident, change pen size by 1. And you don't want them using that one. You want them using set pen size 2. Pen is drawing, yes. And the higher number makes the line thicker. No worries. So when space key pressed, and I always have the students look at the code and try to guess what's going to happen so that they're starting to do that logical or that computational thinking, that algorithmic thinking. So when space key pressed, what do you think will happen? Sometimes we even draw it on a whiteboard first. So there, my beetle has moved. And I always ask students, what shape could this be? And depending on what grade it is, I get different answers. But most of them can see that it's part of a square. And so from there, they finish off the square. And I would ask you to do that now, please. See if you can finish this beetle drawing a square. If it keeps going, to reset it, just click the green flag and then run your code. If it doesn't work, then look at what happened, fix what didn't work, and hit the green flag again. Throw any problems up in the chat if something isn't working for you. No left. You can go to the left instead. You can turn to the left. But yes, it is degrees, but you can make a left turn or a right turn. So if you introduce the concept of what turn 90 degrees means, that corner turn, that 1/4 turn, or the fact that it makes that nice straight corner, then this will work for them. And once they understand what it means, I have grade 1s do this all the time. David, that's a great point. Bring it into sports. Mumtaz, maybe Susan can troubleshoot with you. I'm not sure why. Coded dance, that's fantastic. Okay, so hopefully you're having success. You've probably done something similar to this, and then I'm a little lazy, so I do this. I can duplicate by right-clicking. Whichever block I click on to duplicate, it'll duplicate that block and the block below it, like so. Adding a loop is the next step, Jennifer, so good for you. This is what students do the first time. And you'll see that they've done a move, a turn, a move, a turn, a move, a turn, and then a move and a turn. So they've got 1, 2, 3, 4. They check it, they run it, and it works. But then I challenge them and say, well, how could you do that with less? And then sometimes they'll figure this out. They could do a repeat block, like so, and repeat it twice, and still create a square. But then I tell them, what if you could do it with even less blocks of code and have less places where something could go wrong? Reset, run it again. So this is how I introduce the control blocks to students. And then this gives them a beginning understanding of how these control blocks make other code do things and work better or more efficiently for us, which opens up a lot of possibilities. Now, if you want to turn this into a super awesome art lesson, oops. Once they understand how the repeat blocks work, then they get really creative. and they start drawing on the stage and creating beautiful things. And once you give them this opportunity, then it definitely becomes an art lesson, and they will find out new ways to do things, and they'll share with each other, and it's really cool. For kindergarten, I don't have kindergarten use Scratch. I have kindergartens use Scratch Junior generally. Okay, good. So what I'm going to do, just for the sake of time, hopefully everyone's good with this program. I'm going to move on, just to save time. Daisy the Dinosaur, what I didn't like about it was it didn't speak to the children. They had to read just to use the app. The actual coding was fine, but that part I wasn't a fan of. I typically now pretty much work with Scratch Junior and Scratch, other than Lightbot, which I also find is really neat. And I'm not disclaiming that saying that other things aren't great. I'm just saying those are the ones I find work well. Out of Code is a great starting place, especially for if you're getting a teacher that hasn't used it to work as well. Lightbot PD, I don't know. Okay, so if we hop out of 2D shapes, and I'm going to pop back into the slideshow again. Codable is fantastic for kindergarten students at the very beginning as well, Jenny. Good point. And Spritebox, my students love that, Mark. They do like to use that program. Danny came here as well. He went to school here. That's awesome that he came to your school. I want to see the slideshow again. Here we go. So, and please, let's just so students will reflect on what they've learned, and that's related to the next thing we're going to do. So reflecting both what they do offline as well as online is important. So looking at something they do with coding and then looking at how they use it when they're not coding but still trying to think logically through a problem is something that's great to do. And Laura, that's right. So physically walking the directions. And this program, what I'm going to talk about here, is a little different. So what we're looking at now is, this is some of those control blocks. And if we just look at this code now, pick a random number between 1 and 3. If that number equals 1, then say yes for 2 seconds. If that's not true, so the else is pick a random number between 1 and 3 and it equals 2, then say no for 2 seconds. And then if that also didn't happen, the final choice is that it must be 3, and then say try again for 2 seconds. So in helping students to read this code and think about it, I have them actually act it out. They get cards, and they can write the numbers 1, 2, and 3 on the cards, and they do this physically with other students. So they'll shuffle the cards, someone will ask them a yes or no question, and then they follow this code, they pull out the card, and they give them the answer based on if it's a 1, a 2, or a 3. After we use this to get started, then we take that and we apply it into the actual Scratch program. So I'll pop out again. Susan, if you could share the Magic Hat Probability Program link, please. I'm just going to take people there now, and we'll run through this quickly. Where's my Magic Hat? Okay. Also, when I click the green flag, you're going to hear me talking. One of the great things for the younger grades with Scratch is that they can record their voice. So they can share their learning with you, they can do some coding, but they can also record their voice explaining to you what they did with the code and how it related to the math they've been learning. they can say everything and record it right into the program for you and then share it with you so you have that vocal recording.
I'm a magic hat, and you can ask any question you like. I will answer yes, no, or ask again. Click on me and ask your question, and I will answer.
Okay, and then I did 2 recordings on purpose because I get the students to play with weight blocks, and they have when the recording starts, Scratch doesn't recognize how long it is, so they have to manually put a weight block if they have more than one vocal recording to make it match. And I absolutely will show you how to record it, Deanna, in just a second. So if I click the hat and ask it a question, is it going to snow soon? No! Excellent. So it's just running through this code here. The part that I showed you before is right here. And hopefully this is big enough, but probably isn't, so I'll just enlarge it. So here, this is what we saw on the screen previously. Pick a random number, and then above that, all I did here was I just set up a little repeat 4 times, turn one way, wait a third of a second, turn the other way, wait a third of a second. You have to put the wait blocks in because everything is instant on a code program. So if those wait blocks weren't there, then what would happen is if I put the 2 turns in and I click the sprite, you would say it didn't move, it didn't turn, but it did. But it just did it instantly. And it did it so fast that your eye couldn't pick up on it because it happens instantly. So the wait blocks allow the hat, oh, they're so big they won't go back in. The wait blocks allow the hat time to slow down so that our eyes can see what it's doing. And then we just click the blocks back together. So to record your voice, if you click on sound blocks here, and it'll say play sound. If you pull out the play sound block, and you click on the little black triangle beside recording 2, recording 1, and click on record, the first time you do this, it'll probably ask you twice if you're allowing the microphone to be used. Just click allow, and there's often a second window will come up in the web browser itself that'll ask if you allow it, so both your computer and the web browser. And if you allow it both times, then you click the record button here. Oh, here it comes. Okay. Hi, this is a recording, and I am a magic hat, and I am going to move. Okay. Hi, this is a recording, and I am a magic hat, and I am going to move. So you can edit this, you can cut it, you can copy it, you can delete it. There's lots of ways you can play with this. You can also have it fade in, fade out, make it louder, softer. I've never actually tried reverse. Actually, no, I have to try reverse. Okay, maybe we'll skip that one because, yeah. All right. So that's the Magic Hat program. I'm going to move on again unless anyone has any questions. Okay, so just representing things in different ways. So patterning is another one that's popular in Scratch. So I just touched on the fact, right in the math processes, it does mention physical on-screen dynamic representations. I think a lot of that was there was graphing programs at that time that were popular, but we can take patterning here and we can have the students work on a pattern, but then they can do the reverse as well. This is a shrinking pattern, but they can also work on a growing pattern. So if you want to jump into the patterning project now, So for the students, this starts with 300, 290, 280, 270, 260. If these numbers are too big for your students, it's okay to change these and to make the number smaller. It could be 100 steps, 90 steps, 80 steps, if that works better. But just this creates a larger pattern on the screen. And then the students can try to continue this pattern and move the car closer and closer. And then as soon as they've done that, what I usually do is allow them to go and start creating their own projects. And then they can create a growing pattern, and they'll do different things. So they'll make stairs that go up, and they'll have things going down. They'll have it change colors, because they just start to play with the different blocks. Under looks, there's things we can do in looks and have things change. If we go to the sounds, you can have them create a pattern where it plays different sounds each time the car turns. It can play a different sound, or it can create a repeating pattern with sound that happens while it's doing the shrinking pattern. You can go to the pen, and you can have it change the pen color each time in here, so that each time it will change the pen color. And there's just so many different ways that they can make it their own, and they love doing that. And then they can add those attributes to their project. After students have done the shrinking pattern, then I ask them to code a growing pattern as well. Okay, any questions about the patterning that I'm showing here? I'm not trying to rush too much, I just kind of want to keep going. Undo? No, there's no undo, unfortunately. But what you can do is you can click the green flag again, and if you save the original project, you can just go back. David, could you explain what you mean? Sorry, I just don't want to... Yeah, not with the primary. I do start to have them, they can start to put that code in grade 4. Some grade 3s are ready for it, but it's definitely more challenging for them. So they can create this with a lot less lines of code, but it is tricky for the younger kids. So I generally don't go there with things like this. I keep it pretty simple. It's more about they'll start to discover that as you introduce things. In grade 4, we start to do a bit more of that. When I have the chance, I do with some students, but it depends on the students definitely. Okay, I think we're doing pretty good now for time. So once the students have been doing a bit, what I do is I take them into... Oh no, this is not the right one. Sorry. I haven't done my leaf one yet. So my class went outside a couple of weeks ago, and we collected leaves on the playground, and we measured, basically, we didn't call it the perimeter, but we measured the perimeter of the leaves. We measured around the outside of the leaves. We've been doing measurement. So we talked about units of measurement. We found leaves out in the yard that we could measure in millimeters, and we found leaves that we could measure in centimeters, and it was a great experience. Some of the leaves were quite large, so it was fun for the students to do, but it was also very practical. Then what I wanted to do was I wanted to bring that into the digital space, and so have them use that code to measure around the leaf as well. And so here, I'll show you how I did this, but I've imported an image of a green leaf, because sprites can be anything that you upload to Scratch. And I uploaded a green leaf. It doesn't have to be a green leaf. I could actually get rid of the green leaf, and to get an image that will upload nicely into Scratch, if I want to look for an image of a car, I'm going to get lots of images. But if I downloaded this image, you can see here, I'll have that white background behind it, and that doesn't look nice if the students change their background. So if you look up car PNG, then what you'll start to get is images of a car, and I'm not getting them, interestingly enough, but usually you can get pictures of a car that don't have a background. And then always, I show my students right away, no matter how young they are, that we're looking for pictures that are available for non-commercial reuse with modification, because we're going to change things about them on Scratch. And this way, we're not stealing anyone's picture. And then we have to find pictures that are PNG files, which somehow I've managed to be unsuccessful finding. Which is funny because I did this earlier and it did work. This one works. So when you find a PNG picture, this is how you can tell. When you click on the picture itself, you'll see this gray and white background, and that means that it's transparent. So if you've ever done things in Google Drawing, you'll see that Google Drawing by default has this checkboard background, which means it's a transparent background. Yes, thanks, Stacy. So if I wanted this picture, I would click on View Image, and then I would save the image, and we'll put it on the desktop. If I go back to Scratch, I can click on this Upload folder right here, and I can upload the sprite from my computer. And if I upload the car, if it's too big, up here beside the scissors, which will cut a sprite, you have a grow and a shrink function. And then in the middle of the car, if I click on shrink, it'll make the car more manageable. And then if I click away from it, then I can drag the car and put it wherever I want it to be on the screen. I can pull my arrow and set it up here to measure around the car. And then all I have to change is the XY so that it'll be in the current position beside the car. So I'm going to go back to my Leaves project. I'll just show you how the code works. So for the students, we would talk about, okay, there's no instructions for this program, and you could have them do a writing assignment where they have to write the instructions out to help a student use this app or this application. So they would look at the code and write out the instructions explaining to another student how they could use this program. So they'll see that the right arrow and the left arrow move. Once I click green flag, will move the arrow, which, okay, coincidentally it's an arrow, but pushing the right arrow key and the left arrow key on the keyboard will move the arrow slightly. And then when the space key is pressed, my arrow will jump forward. And I originally had this at 10 steps, and my students in my class changed it to 30 because they wanted it to be closer to centimeters. So they decided that would make it closer to centimeters. But you can have the students draw around the leaf this way and measure. And then if the students are keeping track of this by counting it, you can do that once, and then you can introduce them to the idea of variables. So an all a variable is a piece of code where it's just like in math, a variable in math. So if I click on data, and I've already created it, so you'll see it on your project. But all we're doing here, I created the variable length, I called it length, and then I can do things with that. So I want to set the length to 0 at the beginning, and each time the space key is pressed, I want to change length by 1 so that we're counting for the students. The program will count how many times they move. Oh, and then if the length isn't showing, just click the check mark beside the length right here. And then that way the students can have the program check for them if they counted accurately when they do it a second time. This will naturally become a part of any games they make because they'll want to keep score. I haven't seen anything in the chat room for a little while. Are people keeping up? Am I going too fast? Okay, good. Stacy, one click equals, one space click equals moving 10 steps. Yeah, for measuring. So the one click that's the unit that they're measuring with, which 10 steps is actually 10 pixels. And if they, like my students, they changed the one unit of measure from 10 pixels, 10 steps, to 30. Gurpreet, I know exactly what you're saying because when I first started using Scratch and I jumped in with both feet, I felt the exact same way. Don't be afraid to start really simple with the kids and just go in and do something like the circles or having the cat move on the screen. I've done another webinar that is on the OTF Connects website, has simple starter projects there as well that you can access. And it doesn't take the students, Susan's saying that as well, it doesn't take the students long to jump in and start to figure things out, and they help each other. They'd love it. Okay, webinar. Susan, I'm not going to remember that. Mark, I'm really sorry. If you search under my name, it will come up. If you look under Scott McKenzie, I believe it comes up and you can access it. Sorry. Okay, I have a little bit of time left. I'll show you one more because I haven't shown you all 5 strands yet, and I want to make sure I give you what you came for. So, I'm not even going to go back to the slideshow, sorry. I'm just going to jump right into sorting sprites. So this is an example of where students can kind of just jump in and do something. So I'll enlarge my code here. There's not much code in this program. This is where they're starting to apply a little bit of what they've learned. So when I click the green flag, it starts with a cat just saying, can you sort these creatures? And then, what's your sorting rule? And what all students need to know to use this is, let's say we go to the crab. The crab shows up when the backdrop switches. Don't worry about that. When the green flag's clicked, it hides and goes back to its original position. So this just sets up the program. But if I want the crab to move, the students can say, I want to move all of the creatures when I press the space key. So I'm going to say when the space key is pressed, I want this crab, because he walks, I want him to go down to this corner of the screen. Or maybe I want him to go up to this corner of the screen. And so all they have to do is drag the crab where they want him to go. And remember that the X and the Y changes for them when we move the crab. So I'm going to say I want him to glide for 1 second. If you do it for longer, it just moves slower. The position numbers, I can explain that at the end. For students, I don't explain that right away. I explain it later. And I will explain that to you in just a little bit. But by dragging it, it will go to that position. The butterfly, I'm going to click on the butterfly now. And, oh, I was already playing with this. So I'll pull that out. I want the butterfly to go down here. So then I pull out glide to this position. And I can go through all the creatures, but basically, when they start the program, if they've set everything up, I press the space key, and now I'm sorting the creatures based upon different rules. And it's totally up to the student. So they'll find so many different ways to sort just these sprites alone. And then they share with each other, and they're talking through it. It's like doing a math talk where they're looking at different ways of adding numbers or whatever it is that you're doing. Well, when you're sorting, they have different ways. They can share their project in front of the class, plug it into a projector, and talk about it. And it helps others to start to see things. Yeah, absolutely, David. Nice. The attributes come up a lot when they do things like this because they can pick sprites. So then let them go in and pick different sprites to use. Now, just to touch on what the numbers mean, on the stage itself, there's a backdrop that you can select that will show you the X, Y positions. It's not super great for showing students. It's not really how I introduce it with students, but you can see that X runs, and it's an old 4:3 ratio, so it runs from minus 240 to 0 in the middle to plus or positive 240 on the right. The Y-axis runs from a maximum of a positive 180 at the top, 0 in the middle, minus 180 at the bottom. This allows students to change position on a grid, which is in our curriculum. But in the older grades, that's when they start to move into these different positions because we have positive numbers here in this quadrant, but then we have positive and negatives showing up, and then negative numbers showing up. So there's just so much more you can do with Scratch. There's so many ways you can carry it into the older grades when the students are ready, and even things that they use now that they experience now, and you label it or you explain it later. So even though they don't necessarily understand all of the math that they're using, it's something that can be built upon later. Mark, that's a great point. I use Scratch actually in every subject except gym. And I probably could use it in gym. I've used unplugged coding in gym, but we love our gym, so we stay away from that. Absolutely, David. You could focus on the positives. You'd be surprised, though, how quickly the younger kids get the concept of the negatives. It just is where the number is and where it goes. It's not relevant to understand the position numbers in order to use the program. It's something that you can introduce to the students when they're ready for it developmentally, and that could be some of the students in your class, but it's not necessary for them to use these programs the way that we're introducing them to them. Okay, so I should jump back to the slideshow. And Scratchwork and just that one. No, Deanna, there isn't. That's why I don't really talk about those numbers. I just explain to them that when they pull the sprite around, that they can set the position on the screen. And I would say that if students have been using Scratch in grades 1, 2, and 3, and 4, by the time they get to grade 5, I don't think they'd have any problems with the quadrants. And I'm saying that just because of students I've taught, how they're getting concepts better I was shocked by how well my students understood angles. I drew a circle on the whiteboard the other day, and I wanted them to understand how to draw the 2D shapes. So I drew a circle, and I asked them, I said, I put a little challenge on with code, and it was going to make 2 shapes. And what it did was it created a square, but the square started turning 1 degree at a time. And the square turned 1 degree at a time and kept going 360 times. And the square basically drew a circle. And so once I showed them that, I drew the circle on the board, and I put a square inside the circle with the 4 points touching. But then I said, what about another shape? And then we did an octagon with all the 8 points touching. And then we did a triangle, and we tried all the different shapes, and they were successful doing it, understanding it better, because they understood that any of the shapes, the angles, all multiply to 360 degrees. And once they understood that little secret about coding 2D shapes, I had grade 2 students who were creating pentagons and hexagons. They just go on to the calculator on Chrome, on the web browser, and they just divide 360 by however many sides they want their shape to be, and they're getting that concept because it's relevant to them and it makes sense with what they're doing. Okay. Susan, I think I've covered the different projects I was going to do tonight. Is every rectangle square? That's exactly right. And so if they've been coding it, they should be able to figure that out. Nice.
Okay, so maybe since it's 9 o'clock, I will jump in and do a couple of quick things. And then if you still have questions for Scott, by all means, put them into the chat, and he will be hanging around here for a little while. Scott, thank you so much for a great session. I think all of you felt Scott's passion for this topic. And Scott, you have a really nice way of breaking things down and making it accessible for all of us at our varying levels of comfort and experience with coding. So thank you very much to you, Scott, for bringing this to all of us. And thank you to all of you in the group tonight. We had great discussion, lots of questions, lots of answers, lots of sharing of other resources, and that's really beneficial. So I'm going to stop the recording and then talk about a couple of things around feedback. But thank you, everyone, and hopefully you'll make good use of Scratch in your future.